Okay, let's get on to this. So we finished the last one, and I gave you the cross product of things. I think what I'll do is pop that back in here for a second so you can see it, and go here, and let's see if I can do. Okay, come on, I'm going to copy this. Not that easy. Okay, let's do it the hard way. It's not going to work there either. Well, I'll just rewrite it. But I want to show that to you. So as we get into this, we started with this bit from the last video. Sorry, I could have had this all tuned up for you and I didn't. So we wrote v of x is equal to py q of x minus pz q of y. V of y is equal to p of z q of x minus p of x qz, and then v of z is equal to p of x qy minus py qx. Okay. There's some fun with that equation too. When you get to linear algebra, remember this and you're going to see how this works. Okay. So here's how we can write this. Okay. So we know the i's and we know the j's. Okay. So we know everything that's going to be in here. So I'm going to rewrite this as v is equal to the matrices of I, j, k, and I'm going to have p of x, p of y, and p of z. Okay, and q of x and q of y with q of z. And then we put the bars on it, and that identifies a linear algebra matrices. Okay. Now we get that if we look at all the places we come up with this. If you're careful, you're going to see patterns start show up. So if I look at the z here, p of x, q of y, and I'm going to divide this way in a minute, p of x, q of y is the z portion of that vector. And then p of y and q of x is the other component. Okay? And I'll show you how this works. But here's the fun with this, and something I always enjoyed as a student, but I really like trying to explain this to people because it is so much fun and also at the same time confusing. Okay, so we're going to write it out like this, and what I did is I repeated the I, J, K, and then I'm going to copy the first two columns over again, and we're going to do the cross product. So we're going to do p of x, p of y, p of z, and then I'm going to come down here and do the q of x, q of y, q of z. And as I said, copy the first two columns over, and we're going to do p of x and p of y, and then we're going to do q of x and q of y. Okay. Now, a ruler will help make this a lot simpler for you. So, first direction we're going to go this way. Okay. And I think I'll use green. So I'm going to draw a line through. No, that's black. Let's undo that. Green, please. Green. I'm going to do a line like so. And then I'm going to come over and do another line this way. And then a third line that way. And then I'm going to twist and go this way. Okay, and let's do that one in blue. And I keep picking up all the places where I can do the diagonals on things. Alright, So that's the solution to doing that. Let's get rid of the ruler for a second here. So if I look at this, I am literally multiplying I, P of Z, and then I'm going to lump all of this together for a solution. Okay, and then I'm going to lump all of this together for a solution. Kind of see where that's going? Now, let's put some numbers in this. It'll make a little bit more sense and get you to a point of being somewhat in a happy place, maybe. All right, so I'm going to use the following numbers in this matrix. Okay, I'm going to use I, J, K, and I'm going to do a 2 by 3 matrices. Okay, so we have two components to this or 3 components with 2 different vectors. And we're going to do 2, 1, and 3, whatever units, be it millimeters or then we're going to do, keep the math simple, I'm going to do all ones in the bottom row here, okay? So again, this is a linear algebra matrix. Don't panic. It'll come to you down the road and make sense. Okay, so the vector of V is equal to, I'm going to do the products like so, but I got to pop over I, J, and K. So I'm going to cheat here in a second for this video. It'll be easier if you write the numbers out again on a piece of comp paper as you do it, because then you can actually get your rows and stuff to line up. Alright, so I'm going to do this. And I think I used green up above for these. Nope, that's black. Let's try that again. Get green. And you don't have to get in fancy colors. Years ago when I learned this, we just did it with a pencil. And that's all there was to it. And I want this one. Okay. And all I'm really using the lines for, folks, is to make sure that I literally get the cross products of all the components. Okay. And when I'm all done, I should have nothing left in in this position or this position. Shouldn't crisscross there. Okay. All right. So that's the cross, and it's the product because we're multiplying 1 times 1 and 3 times 1 and 2 times 1 and all that sort of fun stuff. So anyways, this looks like this. So we do 1 times 1, and that's my I. So 1 times 1 and I plus 3 times 1 is J. 3 times 1 is J. Plus 2 times 1 times K. Okay? And then I'm going to go the other direction. Now, when I go the other direction, this is a unique characteristic that you'll get in linear algebra, but it's all part of making determinants. We're going to go we're going to go a negative. So I'm going to do a negative here, and we're going to go 1 times 1, and that's K. Okay, minus a 3 times 1 I minus a 2 times 1 J. Okay, and again, make sure I got all that stuff. So if I'm going that direction, it's positive. If I'm going this direction, it's negative. So keep that in mind as you play this out. It'll help sort things out for you. All right, now let's bring things together. So I can do this as 1 times 1 is 1, so 1 times I. Okay? Minus, that's an J, let's do an I, minus my other I is 3 times 1. So that's 3I. Let's put those inside of parentheses. Plus 3 times 1J is 3J. j minus the 2 times 1 is 2j. Okay, and again, if you like doing this, you can do this on your paper if it helps you do this. Okay, just making sure you get everything in here. Engineers aren't accountants, but sometimes it helps to think like that. Plus 2k minus 1k. And 2k minus 1 times 1k is that. When we get done, we are literally going to bring everything out. 1 minus 3i plus 3 minus 2j plus 2 minus 1k. And we're going to get this, negative 2i plus 1j plus 1k. And we are going to see the final answer that should look something like this. Minus 2i plus j plus k. And that's the answer. And what this means is we have the vector v solution is negative 2 in the x-plane and plus 1 in the y and z planes. And that is your solution to that. And that's how that works. Okay. We'll do an example and get this set up for you, and we get to doing some homework examples here. But generally, that's all there is to this. Have fun. See you in the next video.